Good morning, my lovely kiddos and my future mathematicians. Today we are going to be talking about 7.3a. We are going to be using the properties of parallelograms that we talked about yesterday. So before we dive into using these properties, let's go ahead and review the 5 cool rules from parallelograms. I'm going to write these on a separate little sheet of paper here so that we can go back and reference them for all of our examples. So our first cool rule for parallelograms is that our opposite sides are congruent. Our second cool rule is that opposite angles are congruent. Our third cool rule is that the opposite sides are parallel. Our fourth cool rule is that our consecutive angles are supplementary, which means they add to 180. Kind of cramming this in there. And then our fifth cool rule is that our diagonals bisect or cut in half each other. All right, so let's go ahead and use these 5 cool rules in some examples. All right, so in this first example, we have a parallelogram and we have our side lengths, and we want to decide, is this a parallelogram? Okay, so we have to use our given information that we know that the left and the right side are both 9 units long, and the top and the bottom part of our shape are 12 units long, and we have to decide if it follows these rules to say if it's a parallelogram. Okay, parallelograms follow all 5 of these rules, but the only thing we know about this shape is its side lengths. So we can't say that the opposite sides are parallel because we don't know the slope. Or we couldn't say that the angles are supplementary because we don't have the angle measures. And we can't say that opposite angles are congruent because we don't have the angle measures. And we can't say that diagonals bisect each other because we don't know the diagonal lengths. So the only thing that we know, the only rule that we could use is rule number 1, that the opposite sides are congruent. Remember, opposite or not touching, furthest from, are congruent. So our left and our right side, those are not touching, those are not connected, and they are congruent. They're both 9 units. And then our top and our bottom, which are not touching, they are opposite. Those are both 12 units. So our opposite sides are congruent, and we don't have any information to prove the rest of them. So I'm going to say that yes, based on our information, this is a parallelogram because the opposite, and I'm abbreviating this, sides are congruent. All right, looking at number 2 here, we are trying to decide if this shape is a parallelogram. So we are going to use our 5 cool rules and the information given to us. So again, we don't have any angles and no diagonals. So we only have our sides lengths. So we can't use that opposite angles are congruent. We can't use that opposite sides are parallel. We can't say that consecutive angles are supplementary, and we can't say that the diagonals bisect each other. So the only rule that we can use that is given to us is that the opposite sides are congruent. So again, we see that the left side and the right side, the 2 sides that are not connected, they are congruent, 3 and 3. However, the top and the bottom, those have different lengths. The top is 4, the bottom is 5. Since those are not congruent, this is not a parallelogram. All right, in example number 3 here, we see another shape and we're trying to decide if it is a parallelogram. This time we do not know our opposite side lengths, so we can't use cool rule number 1. We do know our angles, so maybe we could use number 2. We don't know this if the sides are parallel. We have our angles, so we could use cool rule number 4. And we don't have our diagonals, so we cannot use number 5. So let's go ahead and look at 2 and 4 to see if our opposite angles are congruent and our consecutive angles are supplementary or add to 180. Okay, so we see that our top left angle and our bottom right angle are both 100. Those opposite angles are congruent. Awesome. On our other side, we have 70 degrees and 90 degrees for these two opposite angles, and those are not congruent. So we already know that this is not a parallelogram. And just to kind of prove that point again, number 4 said the consecutive angles or the angle on the same side connected by a one of the sides here, those are supplementary or they add to 180. On our right side, 100 plus 70 gives us 170, not 180. And on our right side, we have 100 plus 90 gives us 190, not 180. So this is definitely not a parallelogram. Okay, for number 4, we have our diagonals here. So we can't say that opposite sides are congruent because we don't know our side lengths. We can't say that opposite angles are congruent because we don't know our angle measures. We can't say that opposite sides are parallel because we don't know the slopes. We can't say that consecutive angles are supplementary because we don't know the angle measures. So the only way that we could prove that this is a parallelogram is by seeing if the diagonals bisect each other or cut each other in half. Okay, so if we see this this diagonal moving up and to the right, this has been bisected because each half is congruent. They are both 8. However, our second diagonal moving down into the right, this has not been bisected. This top half is 7, this bottom half is 9, and those are not congruent. So this is also not a parallelogram. For our 5th example here, we have our angle measures. So we can't use that the opposite sides are congruent because we don't know the side lengths. We can't use that the opposite sides are parallel because we don't know the slopes. And we can't say that diagonals bisect each other because we don't have the diagonals. So we could use that opposite angles are congruent and that consecutive angles are supplementary to prove that this shape is a parallelogram. So opposite angles are the angles that are not connected. So our bottom left-hand angle and our top right angle are both 60 degrees, so they are congruent, which is awesome. And then our other two, our bottom right and our top left, those are both 120, which are also congruent. So by cool rule number 2, this is a parallelogram, but let's double check with rule 4 as well because that talks about angles. So on our right side here for our consecutive angles, we have 120 and 60. If we add those together, we get 180, which is what supplementary means. So this is awesome. And then just double checking our very last piece here. Again, 120 plus 60 on these consecutive angles gives us 120, which is supplementary. So yes. So I'm going to say opposite angles congruent, consecutive angles supplementary. And again, I'm just abbreviating that. So op angles congruent, consec angles sup. And then our final example for today, we have lots of information here. We see the parallel markings on our opposite sides. So we know that our opposite sides are parallel, or our sides that aren't touching are parallel. And we have some diagonals, and we can see that they do bisect each other. Okay, on this diagonal that is going up and to the right, they are both halves are equal to 9 units long, which means that they are equal to each other or congruent. And then the diagonal going down and to the right, they both have 1 tick mark, meaning that they are also congruent. So this is yes, we have opposite sides parallel and diagonals bisect.